Hey students, we've got lesson 5.5 here, proving right triangles congruent. So let's get right at it. First off, I want you to list all of the ways you know so far to prove triangles congruent. So we should have side, 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 angle, side, angle, side, angle, and angle, angle, side as our ways to prove triangles congruent. We're going to add a little bit to that list today, but instead of using S's and A's, today we're going to use H's, L's, and A's, and it will only be two things. So these are specific to right triangles that we're going to talk about today. If two right triangles are formed using the criteria for leg-leg congruence, hypotenuse-angle, leg-angle, or hypotenuse-leg congruence, then there is a series of rigid motions that shows the two triangles are congruent. And this leads to the theorems below. So what these theorems all say is if in this case, it's legs of one right triangle, so it's very specific, these are of right triangles, are congruent to the corresponding legs of another right triangle, then the triangles are congruent. So same idea as the setup here, that these are going to be used to prove that triangles are congruent, but they're a little bit different because it has to be a right triangle. So we always had to have three things listed in order to have triangles congruent up here. The same thing goes down here, even though it's called LL. One thing has to be listed that they're right triangles, and then the other two things are the L and the L. So we're going to talk about that idea here. And where that comes from. So if we look at this picture right here, it'll give us an idea of the LL. If you have a right angle, so you have a right triangle, and the legs, so reminder here, this is your hypotenuse of your right triangle, this is your leg, and this is your leg. And then you have an acute angle and an acute angle. And this is the case for every right triangle. So if you keep that in mind as we talk about these, for this one, you have a set of legs congruent and another set of legs congruent and a right angle. If that is the case, these triangles are congruent mainly because side, angle, side works. Now, sometimes you'll want to state that the angles are congruent, but sometimes you already know you have a right angle or a right triangle, and therefore there's no reason to say they're congruent in this case. So that's the first one. The second one is hypotenuse angle. So be really careful with this, but it has to be the hypotenuse of one triangle congruent to the hypotenuse of the other. Don't forget your right angles. And one angle. Doesn't matter if it's this one or if it's the angle D and angle A, but one angle. And what you should notice here is this is an angle side set up in this case. But again, it's slightly different because you are going to say that these angles are right angles, okay? Instead of, or that you have right triangles. So it's one less step. Instead of having to go to this, you can. So you can always use angle side, but you also have HA as a kind of shortcut method, sometimes the longer method. Then you have LA. So if we imagine our two triangles, I'm only going to draw one, okay? We have our right angle. In order to do LA, it has to have a right angle, okay? We have a leg congruent, so just pick a leg in this case. One leg and an acute angle of a right triangle. So if I pick this acute angle here, notice that this is technically angle, side, angle. And if I do the same thing with a right angle, the acute angle, and the other one, then this is technically angle, side. So either one of those kind of leads to this idea of LA. Now, the really interesting one is the HL. So HL is the one that you absolutely have to know, because if you think about this, let's go ahead and draw ourselves a picture of this triangle. If we have a right triangle and we know that the hypotenuse is congruent to the hypotenuse of another one, okay, and then we know that a leg, so let's pick this leg right here, is congruent to a leg of the other one. If you put this in order of what do we have with angles, sides, and sides, we have side, side, angle, which is the bad word backwards. Okay, so if you imagine that bad word, remember bad word means it doesn't work. So this is the one that does not work to prove triangles congruent. And I can show you a picture of pieces that are the same where the triangles are not congruent. The difference here is that this is specifically a right angle. So think about it. When it's a right angle, we can use Pythagorean theorem. And Pythagorean theorem, if we know the distance of this side and the distance of this one, which we don't know an exact right now, but if we know those distances, based on those distances, this has a set distance. And based on that idea, then if I know all three distances, and that's going to be true for the other one, I know all three distances, then side, side, side is really what allows HL to work. So we have to know and use HL within these proofs. The other ones you kind of get away with without, but you're going to be able to use any of those. Now, the question right now is there anything that's like left off? Like, did we miss any combinations or whatever? So if you think about hypotenuse, you can do a hypotenuse with a leg, you can do a hypotenuse with an angle, okay? You can't do a hypotenuse with a hypotenuse because there's not two of them. You can do a leg with a hypotenuse like I have there. You can do a leg with an angle. You can do a leg with a leg because there are two legs. Okay. You can do a angle with a leg. You can do an angle with a hypotenuse. You cannot do an angle with an angle. So if you know the right angle, you know an angle and an angle, that's technically angle, angle, angle. We already talked about the fact that that does not work. Okay, so those are your four options of how to put those together and what works. Again, at this point, if we do all of the combinations of H's, L's, and A's and all of the combinations of S's and A's, we found out that there's only two that don't work, and that is side angle, the bad word backwards, and angle, 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 because that's a dilation. So those are the ones that do not work. Okay, let's see if we understand that. So can you declare that the given triangles are congruent by HA? So here's the thought process is people are like, okay, hypotenuse, hypotenuse, we're good. Angle, angle, we're good. And we have triangles congruent. The problem here is that remember you have to have three pieces, okay? And that angle that is congruent has to be the acute angle of the right triangle. So this right angle is just one here. You would need to know the angles are congruent. So no, you cannot prove these congruent by HA. Let's go ahead and do a proof. So here we've got some fence posts. You can read through the problem if you want, but it's really just about the givens. So we know that angle B and angle D are right angles, so we can see those right angles in there. And we're going to list those right away as given. And then we're going to say that our triangles are right triangles, and this is just based on the definition of a right triangle. Or you can simply say if a right angle, then a right triangle. Now, this is one of those things where I will then take, because we can do this proof real quickly, is either one of these statements will lead to being able to do HL, HA, LA, or LL. Okay, so either one of those, we're going to take that for now. Now, we've done one of the givens. Here's the other given. So we are given that AD is parallel to BC. So AD is parallel to BC. Oh, I'm going to back up one second here. I am going to write right triangle right here. So if you remember how I've been listing stuff on the sides, this one right here, I'm writing right triangle because that's the piece that we need listed over there. Now, AD being parallel to BC, remember either it's going to be corresponding angles or we're going to be looking at for a Z and looking for alternate interior angles. So here's my two lines. There's my transversal. We're looking for alternate interior angles, which is here and here. So they list angle DAC, that's one of them, and angle BCA, that's the other one. So we're going to say if parallel lines, that's what this one's did, then, and we list the type, alternate interior angles, and what do we know about them? Are congruent. Okay, there is a set of angles within my proof. Last thing I have here is I can see it says AC is congruent to AC. If I come up here, that's my reflexive property. So we can list that down. That is a set of sides. So now I have right triangle, angle, and side. Now I'm going to actually change this S, and I'm going to look at this and say, okay, that's my hypotenuse. So I'm going to list that as an H. So I have a right triangle, an A, and an H, and we just write that as HA. That proves that my triangles are indeed congruent. Okay, that's it for that one.